The Tibetan Plateau is sometimes called the roof of the world because it is so high up that the clouds almost touch the mountains. On average, it is more than 13,000 feet, 4,000 meters, above sea level. The air there has very little oxygen, which makes it hard to breathe. Long ago, people thought no one could live in such a place. But today, millions of Tibetans live there. Their bodies have special changes that help them breathe in the thin air. These changes come from genes they inherited long ago, not just from their culture or lifestyle. A long time ago, another group of ancient humans called the Denisovans lived on Earth. They are no longer around, but they left behind traces of themselves in modern people's DNA. In 1980, monks in Baishiya Cave in China found a fossil jawbone stuck in a rock. This jaw was very big and strong, with large teeth and thick bone. At first, scientists didn't know who it belonged to, but a few years ago, they tested its proteins and discovered it was from a Denisovan. This means the Tibetans' ability to survive high in the mountains comes from a genetic gift passed down from the Denisovans. The she-mandible is more than just a fossil. It is proof that Denisovans lived and thrived at extreme altitudes. No modern humans are securely documented on the plateau until tens of thousands of years later. But Denisovans were already there in the Middle Pleistocene, breathing thin air and enduring long winters. Their presence rewrote the map of human prehistory, showing that Asia was home to more than Neanderthals and early Homo sapiens. Denisovans and Neanderthals would have had a high probability of contact in the Siberian Alai 340,000 to 290,000 years ago, 240,000 to 190,000 years ago, and 130,000 to 80,000 years ago during relatively warm periods. While Neanderthals preferred the temperate forests and grasslands of the West, Denisovans were much better adapted to colder environments such as boreal forests and tundra regions in southern Siberia and the high plateaus of eastern China and Tibet. Even more haunting are the traces at Kasong, a geothermal area with hot springs in central Tibet. Here, preserved in hardened traverine, are the handprints and footprints of children pressed deliberately into soft mud 200,000 years ago. The pattern is playful, almost like early finger painting, suggesting children marking their presence on a warm, wet surface beside the springs. The most enduring Denisovan contribution, however, is not fossilized bone or preserved prints. It is a molecular adaptation that makes Tibetan life possible. Genetic studies have dated the introgression of this haplet type into modern humans to around 48,000 years ago, with positive selection beginning later, perhaps 9,000 years ago, when modern humans pushed into the plateau more permanently. The Denisovan gene variant spread quickly because those who carried it had a decisive survival advantage in the Himalayas. Today, it is nearly universal among Tibetans, making their existence in the highlands a direct legacy of Denisovans. The Alai was not a quiet refuge, but a crossroads. Neanderthals moved in and out. Modern humans eventually arrived, and Denisovans maintained a foothold through shifting environments. One remarkable fossil, a bone fragment from a girl known as Deni, showed she had a Neanderthal mother and a Denisovan father. This proved that the two groups not only overlapped geographically, but interbred directly. Their northern range likely extended even further into Mongolia and the colder steppe lands, pushing the boundaries of survival in harsh ice ages, according to models by Tim and Edel. The robustness of Denisovan anatomy, hinted at by their jawbones and teeth, suggest bodies capable of withstanding these extremes. In many ways, their northern distribution mirrored that of Neanderthals, but with an eastern orientation. Denisovans and Neanderthals were not isolated populations. Genetic evidence shows repeated episodes of admixture between them. Denisovans carried segments of Neanderthal DNA, meaning they were already hybrids long before modern humans entered the scene. Neanderthals in turn carried traces of Denisovan ancestry, demonstrating a long-standing network of contact zones stretching across Eurasia. These interactions blur the boundaries between species and reveal a pattern of porous lineages. Rather than discrete categories, Neanderthals and Denisovans were part of a continuum, diverging and reconnecting over hundreds of thousands of years. By the time modern humans interbred with Denisovans around 50,000 years ago, those Denisovans were not genetically pure. They were already admixed with Neanderthals, and thus the Denisovan legacy carried into us was also partly Neanderthal. This helps explain why some Denisovan segments in modern human genomes are difficult to pass. They carry the signature of two archaic lineages woven together, a genetic braid shaped by millennia of encounters. Denisovans were not confined to Siberia. Fossil and archaeological evidence reveals their spread into Tibet and Central Asia, where they became pioneers of high-altitude survival. The Shiai mandible found in Baishiya Cave on the Tibetan Plateau dates to around 160,000 years ago. It is thick, heavy, and crowned with murs the size of walnuts. Protein analysis confirmed it belonged to a Denisovan. This fossil alone rewrote the map of human history. It proved Denisovans lived not just in caves of the north, but in the thin air of the Himalayas. Modern humans would not securely reach the plateau for another 100,000 years, yet Denisovans had already mastered it. Their physiology and genes carried the secret. Nearby at Kisang, preserved travertine revealed the handprints and footprints of children pressed into soft mud between 169,000 and 226,000 years ago. These were not random accidents. The impressions appear deliberate, as if children pressed their hands and feet into warm ground beside a hot spring for play or expression. If made by Denisovans, they represent not only survival, but humanity. A moment of joy frozen in stone long before modern humans ever set foot on the plateau. These impressions, which are now preserved in limestone, provide some of the earliest evidence of human ancestors in the area and may be the oldest art of their kind ever discovered. Scientists discovered the 5 handprints and footprints during an expedition to a fossil hot ring in Kisang, which is more than 13,000 feet, 4,000 kilometers above sea level on the Tibetan Plateau. They dated the sample by determining the amount of uranium, a radioactive element found naturally in the environment present in the prints. Based on the rate at which uranium decays, they estimated that the impressions were left between 169,000 and 226,000 years ago. Based on the size of the prints, the team determined that the marks were left by 2 children, one about the size of a modern-day 7-year-old and the other the size of a 12-year-old. The handprints are composed of travertine, a type of freshwater limestone formed by mineral deposits from natural springs. Travertine, when first deposited, forms a very fine sludgy mud into which one can easily push their hands and feet. When cut off from water, travertine hardens into stone. No modern humans lived on the plateau. Then the most plausible authors of these prints are Denisovans. If so, they represent not only survival at high altitude, but also perhaps the earliest known art in the world, an intentional act of expression frozen in stone. The Ishi mandible tells us Denisovans were in Tibet. The Kasang prints tell us what it felt like for them to be there. These prints are haunting. Unlike bones or tools, they capture a moment of lived humanity. A child kneeling by a hot spring, pressing small hands into soft mud, unaware that 200,000 years later, the world would still read their touch. In the Kasang footprints, Denisovans cease to be a genetic abstraction or a jawbone in limestone. They become people, playful and alive, inhabiting the plateau long before history. However, the most important Denisovan legacy in Tibet is genetic. Tibetans today carry a variant of the EPA1 gene which regulates response to low oxygen. Most humans cope with hypoxia by producing more hemoglobin, which thickens the blood and creates long-term health risks. The Denisovan variant allows Tibetans to use oxygen efficiently without this dangerous response. Studies date the introgression into modern humans to around 48,000 years ago, with strong natural selection acting later perhaps around 9,000 years ago, when humans began permanent high-altitude settlement. Without this gene, Tibetan settlement might have remained temporary. With it, the plateau became one of the most remarkable human habitats on Earth. The precise location of Denisovan modern human interbreeding remains debated, but several regions are plausible. In the Alai Mountains, Denisova Cave itself was a hub where Neanderthals, Denisovans, and later modern humans overlapped. Interbreeding here is well documented, and it is possible that Denisovan genes entered our lineage in this region. In East Asia, particularly China, fossils such as the Harbin skull, the Darley cranium, and the Sujaya remains reveal robust archaic traits that align with Denisovans. Modern humans entering northern China around 45,000 years ago may have encountered Denisovans and acquired key genes. In Southeast Asia, populations in Papua New Guinea and Aboriginal Australians carry the highest proportion of Denisovan ancestry, up to 5%. This implies significant interbreeding in Islam, Southeast Asia, perhaps in Indonesia or the Philippines. While this southern encounter may not have introduced this gene specifically, it proves Denisovans met modern humans in multiple locations. Finally, the Tibetan Plateau itself remains a compelling candidate. Denisovans were established there long before modern humans arrived. It is possible that as humans climbed into the highlands, they met Denisovan groups already adapted to altitude, acquiring genes at the very edge of survivability. However, nearly 1 million years ago, humanity faced a crucible. Around 900,000 years ago, the ancestors of modern humans and their close relatives endured a severe population bottleneck. Climatic upheavals during the early Middle Pleistocene shrank habitable zones, reduced food sources, and drove human numbers to the edge of extinction. Genetic modeling suggests that the global ancestral population may have dwindled to just a few thousand breeding individuals. From this narrowed base emerged the lineages that would later define Eurasia. By around 800,000 years ago, the population had split into at least 3 branches. The ancestors of modern humans, the Neanderthals, who would dominate Europe and Western Asia, and the Denisovans, who would spread across Central and Eastern Asia. This was the moment when the shared trunk of humanity divided into distinct limbs, setting the stage for later encounters, interbreeding, and legacies carried into the present. While Neanderthals became the archetypal Europeans of the Ice Age, Denisovans carved out their domain further east. Their northernmost home was Siberia, anchored by Baishiya Cave in the Alai Mountains. Archaeological layers there reveal occupations spanning hundreds of thousands of years. In this cave, scientists discovered the fossils that gave the Denisovans their name: a child's finger bone, several massive molars, and fragments of long bones. DNA from these remains revealed a population as closely related to Neanderthals as to us, yet distinct with their own evolutionary path. By the time modern humans encountered Denisovans, these archaic humans already carried Neanderthal genes. Thus, the Denisovan DNA within us today is doubly hybrid, a composite of 2 archaic populations. This underscores a central truth of our history. Human evolution was not a story of isolation, but of constant contact and exchange. Modern humans absorbed any genes that improved cold weather metabolism, high-altitude genes that enabled Tibetans to thrive, and other genetic gifts still being uncovered. Denisovans themselves absorbed Neanderthal traits, shaping their biology long before their genes entered ours. Each group was not a closed chapter, but part of a continuous dialogue of interbreeding and adaptation. For Tibetans, the Denisovan inheritance is tangible. Every herder guiding yaks across a high pass, every monk chanting at a monastery perched above the clouds carries in their DNA the breath of Denisovans. The high-altitude gene, a gift from an extinct people, allows them to live where most would suffocate. This is not merely a biological fact, but a profound metaphor for human history. Extinction does not always mean disappearance. Denisovans are gone in body, but alive in essence, carried within millions of people across Asia. The story that began with a bottleneck 900,000 years ago culminates today in the breath of Tibetans standing on the roof of the world. The split of our lineage at 800,000 years ago created Neanderthals, Denisovans, and modern humans. But their paths never stayed separate for long. They met in caves and valleys, on plateaus and islands, leaving legacies not of isolation, but of connection. Denisovans overlapped with Neanderthals in the north, exchanged genes with them, and carried those genes into us when they interbred with modern humans around 50,000 years ago. In Tibet, their most enduring gift remains their genes, a molecular bridge across time that allows humans to thrive where sky meets stone. To tell the story of Tibetans and Denisovans is to tell the story of shared humanity, not pure lines but braided strands, not extinction but survival through inheritance. The Denisovans never truly disappeared. They became part of us, breathing still in the thin air of the Himalayas, where every heartbeat recalls the mingling of peoples long vanished but never forgotten. Thank you for watching and commenting. So, Homo sapiens, I will show you. They will leave Africa around 60,000 years ago. Okay. Oh, right now. Okay. And you see, whoops, all the others are gone.